This is Honors Algebra 2 Pre-Calc. We're doing 6.3 Pre-Calculus, which is vectors in a plane. In this example, we're going to talk about finding a visual representation for how we add vectors. Specifically, we use the phrase head to tail. We add vectors head to tail, and I'm going to show you what I mean by that when we do part B of this example. So part A, so we're given this u, which is 1, 2, and we're given this vector v, which is 5, 6. And we are asked to write u plus v in component form. So that's back to example 3 and example 4. So if I were asked to write u plus v in component form, right, it's going to be the sum of the horizontal components, which is 1 plus 5, comma, the sum of the vertical components, which is 2 plus 6. So I'm going to get that u plus v in component form is a 6, 8. Okay, so that's the answer to part A. Great. Now the second thing I'm asked to do in part B is to sketch what this actually looks like. But I'm going to cheat and skip to C for a sec because we can already do C. If I'm asked to find what's the magnitude of u plus v, right, the quantity u plus v, I'm going to find that magnitude of u plus v, by doing the square root of the horizontal component squared, right, 6 squared, plus the vertical component squared, which would be 8 squared. So that's going to end up being the square root of 36 plus 64, which ends up being a square root of 100, and it's not at all surprising that it's a 10, and I'm going to talk to you about why in a second, but essentially it's because it's a Pythagorean triple. So let's go through. I'm going to color code what these vectors look like. So when I said add the vectors head to tail, here's what we mean. I'm going to sketch my first vector, u, in standard position at the origin. So u, in red, is 1, 2. So I start u at the origin, right? And then I'm going to go 1 unit horizontally and 2 units vertically. So 1 unit horizontally, 2 units vertically, and right there, and again, we all know I draw terribly, but there's my vector u, and it has an arrow because vectors have direction. Now, when we say we add head to tail, here's what we mean by that. For adding the second vector, this vector v, I'm going to draw its initial point, right, its tail, for lack of a better way to say it, because every vector has a head, the part where the arrow is, and the tail, which is that little dot. I'm going to go ahead and put its tail at the head of the last vector. So I had u, and now I'm going to add to it v. Well, vector v from that new initial point is going to go right 5 and up 6. So I'm going to go right 1, 2, 3, 4, 5. And I'm going to go up 1, 2, 3, 4, 5, 6. And right there, I'm going to go ahead and draw my vector v. Okay, so what I want you to notice, so there's my v, and then if in red, I know it's kind of hard to see, but I'm going to put my vector u right here for that red vector, right? Now, what we call u plus v is the resultant vector. So the resultant vector, u plus v, will be the vector I get if I go straight to the end. So this green vector is u plus v. All right, and again, the words for that we usually use are resultant vector. And that's not a fancy word, it's just saying it is the result of doing the operation I was given. It is the resultant vector. So now what I want you to notice about u plus v is if you just looked for the component form of u plus v, well, on the Cartesian coordinates, this position right here is 6, 8, right? So my vector is going from 0, 0, which is where all vectors start in standard position, to 6, 8, and that's absolutely a Pythagorean triple, which I totally did on purpose, right? 6 as one leg and 8 as the other should lead to a 10 as the hypotenuse, which is why the vector u plus v has magnitude 10, because that's a 3, 4, 5 Pythagorean triple. Right, so, but this is how we add vectors, right? We add, and you'll see this a lot when you take like a physics class, because a lot of force diagrams and a lot of diagrams that talk about the way that air hits a plane's wing and other things are going to talk about the direction of some force, and they're going to look like this. Or when work's done on an object, they're going to look like this. And when you add vectors, whatever vectors they are, you add head to tail. So your first vector starts in standard position, and then when you add it, your next vector would be starting at the head of that first vector, head to tail.